Okay, so now I want to let you run through a simple linear program. So as you hear here, we have a problem saying a workshop makes wooden tables and chairs. Let x be the number of tables produced. So let's say we have and y be the number of chairs produced. So we have x here, for example, and it represents the number of tables. And here we have y, which represents the number of chairs. Okay, so just what is right and then the stuff. And so they say to make a table, you need 3 hours for wood cutting. So here we can put like column like wood cutting. And so here it will be 3 hours, as it is written and stuff, and 2 hours for assembling. And they say yes, we can sell a table for 40 euros. And a chair for 30 euros profits. And they say here to make a chair you need 1 hour for wood cutting and 2 hours for assembling. So if you can only cut for wood for 30 hours maximum and sell for 40 hours maximum per week, how do you maximize your profit per week? So we have max of 40x, like this, plus 30y, like we try to maximize the price, such that we have this number of wood cutting. You know that it's 3x plus 1y, and you know the maximum of this should be you can only cut wood for 30 hours, so 3x plus 1y is inferior to 30. That's it. You can only cut wood for 30 hours, so yeah. And assemble for 40 hours, so 2x plus 2y inferior to s. How do you maximize your profit per week? So that is it, and you need to have also x and y being superior to 0, like the number of table and chairs, or it will not make really sense anyway without it. So this is the representation at the end of this, which is the representation of this. Well, if you're smart, you can skip the steps and go from here to here directly. But yeah, I want it to be pedagogical, so I make it like this. And so this is a linear program. Indeed, if you remember what we told about linear programming, is that a linear program follow a structuring thing that we have sub of x then go to r to the power of n c transpose x such that ax is inferior to b and x is superior to 0. So here is the same. We have ax being this and b being this. More specifically, what we have here is like C transpose. It just like C just 40-30. So C transpose is like, if I write it simply for you, C is just 40-30. So the constraint is for constraint. So the constraint is 40-30. So C transpose is this. A is just this 3, 2, 1, 2. B is just this, ax inferior to b. So here b is 30-40. And so yeah. So if we write it now, our linear program in the standard form in a way, if I can allow me the expression, is this. Beautiful, no? Life is beautiful. Here I just mistaken myself. 3, 1, 3, 1, 2, 2. Just replacing the value we find from our problem here to have not an abstract stuff but a real stuff. X and y. X being superior to 0. So that's it.